Hi, I'm Nick Furness and I'm a product manager with the ArcGIS Runtime SDKs. Over the next hour or so, we'll talk to you about building apps with the iOS SDK. We'll cover getting started, downloading the SDK and integrating it with your projects, and then some core workflows of the runtime, working with the map and the map view together, displaying data, interacting with the map view, being able to use the device's GPS, and accessing tasks such as geocoding and routing. And along the way, we'll touch upon a bunch of tips and information for building apps with the runtime iOS. So what do you need to get started? Well, you'll need a Mac, and it should be running macOS 10.14 or later. The current Catalina version of macOS is macOS 10.15. You will need Xcode 11 or Xcode 10. These are free from the Mac App Store. I recommend working with the latest at all times, though. And an Apple developer account. This is now free to get, and you can test on a connected device attached to your computer. If you want to test more broadly and distribute beta versions of your application, then that falls under the mantle of the App Store, and you need to pay the $99 a year developer fee. There is also an enterprise developer account available from Apple, allowing you to build apps for use in-house by your own colleagues and staff and contractors. Then you'll also need an Esri developer account. That's free at developers.arcgis.com as well, or you can use an existing ArcGIS Online account if you have one. The ArcGIS Runtime actually supports iOS 13, 12, and 11 at the moment. That covers a vast range of iOS devices in the field. As of the end of January, well over 70% of iOS devices were already on iOS 13. And the runtime also supports Swift and Objective-C. You can combine them, choose one or the other. It's an Objective-C API, but because of the work that Apple has done, that makes it very easy to use in Swift, and all the code we'll see today will be Swift code. So, to install it, you download an installer package that will install a dynamic framework onto your machine, which you can link into your projects. It includes Xcode integration with API reference, allowing for autocomplete that we'll see in the demos later. It includes a couple of basic starter samples and some legal materials. Or you could use CocoaPods. It's a very popular package manager for iOS development. I personally prefer to use the installer package because CocoaPods actually modifies your project and turns it into a solution. So if you're okay with that, that's fine. There are a lot of benefits to working with CocoaPods. I tend to just prefer the installer. As we'll see during the demos, you can actually just drag and drop the dynamic framework into the project's target to link it. And this is also covered in our documentation. So something to be aware of, Apple deprecated support for OpenGL ES with iOS 12. And what this means is that at some point in the future, they will only support Metal. For now, they're still supporting OpenGL. The good news is that we are finishing off work on adopting Metal and hope to release that with 100.8. Since we'll only be releasing Metal at 100.8, it means that the iOS simulator for iOS 12 and earlier will no longer work with the map view and the scene view. So to work in the simulator, you'll need to be running macOS Catalina, Xcode 11, and be simulating iOS 13. If you plug directly into a device and test your apps on a device, there's no restriction at all. This is just something to be aware of. So let's take a look at what's available to you on the web as resources. I'll jump out of PowerPoint for a second and we'll jump over to our website. So this is developers.arcgis.com. Now we'll start up here in the documentation section and jump right into the iOS documentation. Now here we see some shortcuts to various components getting started, sample code, the API reference. We'll see that some of these are replicated up here at the top. There's a link to download the SDK, instructions to install the SDK. And this actually drops you right into the guide doc. Now, the guide doc has a bunch of interesting and helpful sections here. I want to highlight a few of them. First of all, installing the SDK. We talk about installing it manually, as I mentioned earlier in the slides, or using CocoaPods. And A couple of other sections that are worth bearing in mind here. Check out the fundamentals section. There's a lot of concepts here that are key and repeated throughout use of the runtime, in particular tasks and jobs, working offline, loadable resources, and so on. And a couple of other things I just want to highlight really quickly since we're here is the reference section, which includes system requirements and release notes and the like. And then this section, Release Your App, that talks about licensing your app. So it talks about the code required to actually set the license in your app. We can scroll down to the bottom here and start seeing some code snippets. But also useful here is a table of capabilities. So I'll just highlight some of these really quickly. Now with the light level, you can actually do most of what you probably want to do with the runtime. You can work online or offline. You can do offline geocoding, offline routing. You can navigate maps and so on and so forth. You can even edit completely public feature services. That means they are public and available to anyone, and anyone would be able to edit them. So the usefulness of that is slightly limited, but you do get a lot of functionality here directly at the light level. When you go to basic, that's really about editing and creating content, whether it's your own data through feature services. You can edit online or offline using the basic level, or creating content in ArcGIS Online, creating new web maps, saving them to your enterprise account to ArcGIS Online. That's all available at the basic level. Also, we have the navigation API, and that also requires basic. The standard level introduces really support for local files, working with geopackages, shapefiles, local raster layers, and so forth. It includes the visual analysis capabilities. And then the advanced level really isn't relevant to the iOS SDK. It's really just adding local server support, which is only really appropriate to Java.NET and Qt SDKs. So next we can jump to the API reference, and this is really getting to the meat of things. Here we can search for specific classes in the runtime, and you can see there are hierarchies here. We can learn about marker symbols, picture marker symbols, and so on. On the left-hand side here is the entire class list of the Runtime SDK. So this is really where you go to get your specific documentation on individual properties and classes for working with the runtime. Now that's great for understanding what each individual call does, but how do you actually learn about what you want to be working with? That's done here in the sample code section. So we have very in-depth sample applications. You can actually jump over to GitHub and see these samples. They're completely open source. But we can also, this is also available in the App Store for download. So if you don't have the ability to build this, you can go ahead, download it, and explore the capabilities of the SDK. So let's, for example, just take a look. We can search for samples here, and we can jump in here, see the sample, learn a little bit about how it works, see the code behind it, or jump right over to that code for that sample in GitHub. Not only is it available in GitHub and on the developer's site, but you can see the application downloaded from the App Store too. So here's that same sample. This is the viewshed location sample. And I'm going to go ahead and just interact with it here. So I'm moving the map around. If I tap on it, it places a location. And as I'm walking around, this is doing an interactive viewshed directly on the device. So we saw the code in GitHub. You can also learn about this sample directly in the sample app. And you can see the code here and see exactly what code is required to make that sample come to life. So you can download that or build that for yourself. Related to the sample app is the open source apps. I just want to cover that really quickly too. So if we jump back to the SDK's homepage here and we scroll down a little bit, we get some links to tutorials, more on that later. But we also see these open source apps. So the open source apps are applications that we've built here at Esri to demonstrate best practices for building your own applications. You can take this code, it's open source, available for different runtimes, and use it as the basis of your own apps, or take whichever pieces you need and integrate that with your own apps. So these are GitHub projects that you can download, work with, fork, clone, make PR, pull requests against, and so on. I do want to just cover a couple of other things really quickly. If we go back to the developers homepage, there's a Getting Started section. This is a bunch of tutorials. We can jump into these tutorials filtered by iOS, and they're all very quick. You get a vague indication of how long they'll take, but they're very, very simple. They start with a beginning project, and the beginning project is actually also itself a tutorial. So you can download the starting point, go through these steps. They're very, very simple and straightforward, and end up with a result. You can compare your result to a completed solution as well. So we allow you to download the finished project and the starting project. We also issue some challenges that invite you to look into the documentation a little more and learn some more about what you've just learned and expand upon that. And also we provide related and next suitable tutorials to follow through with. The very last thing I want to cover, if we scroll down here a little bit more, we see some of the capabilities of the SDK. So if you're of the ArcGIS developer tools in the SDK and the platform. So you can explore here and learn a little more about what's available to you and what you'll be able to work with. And then we also have some success stories. So here we have customers and your colleagues and peers who have built applications using our various SDKs and APIs. And you can jump in, learn about what they've built, how they've built it, and jump directly into documentation that's appropriate to what they've been building. So let's jump back into some slides. Let's start talking about some core workflows. So we'll look at code in just a second, but before we do that, I just want to cover a key concept. So we have this concept of a map, which has operational layers sitting on top of the base map. We also have a parallel of a scene, which also includes an elevation surface. These are essentially the models. They could correlate pretty strongly to a web map or a web scene. And then they work very, very closely with a map view and a scene view. And these are the UI components that you embed into your application that work with the map to present it to your users, to handle user interaction, and feed that interaction back to you. So with that in mind, let's jump right into our first demo of just creating a map and doing some geocoding. So let's begin with a completely blank Xcode project. I'll create a new Xcode project here. It's going to be a single view app. I'm going to call it Building iOS Apps, because that's what we're doing here. We'll use a storyboard. SwiftUI isn't quite where it needs to be for us to work with it yet. We won't include any unit tests for right now. And we'll just save that to my desktop. Okay, so I'll now add the ArcGIS Runtime Framework. Here we can see in my home folder, there's a library SDKs ArcGIS folder. And under here is where the runtime is installed when you download it. I'm just going to grab this ArcGIS framework and drop it into Xcode here. So right now, when Xcode created this project, it created the project structure. It has a single target. That's the binary that's going to get built and put on the phone. And here under the general settings in frameworks, libraries, and embedded content, we just drag that framework in. So now the project is linked to our to the runtime framework. So I'm going to create a map view. So the main storyboard describes the visual display of our app. Here we have a top-level view managed by this view controller. I'm going to create a sub-view in that top-level view. So I click on the plus button up here to add objects. I'll add a UI view. I'll just drop that in here. I want to make that fill the parent view, so I go down to the constraints icon here. This is a little TIE Fighter icon. And make sure it has 0 distance to its parent view all the way around. It's taking account of the safe area too. You can see we now have a view within the top level view. Now we want this to be a map view, so I jump over to the class settings here, and I'm just going to say ArcGIS map view in here. You can see on the left hand side here that's reflected already. In the editor we can pull up the assistant editor now, and that brings up the code that goes with this storyboard. You can see here we've got a view controller. That's the view controller code behind it, and all I'm going to do is control drag from the storyboard into the code and create myself an outlet. This is the binding between the code and the storyboard. When we go to the view controller, we can see we've got that defined here. So now we can start referencing that map view UI component from our code. Well, Xcode isn't very happy at the moment because it doesn't know what an ArcGIS map view is. That's because I haven't imported ArcGIS into this particular Swift file. Once I have, Xcode's happier, and it's as simple as saying mapview.map equals ArcGIS map, and you can see we've got some autocomplete going on here. I'll tap down here, press enter, I type dot because this is an enumeration, navigation vector, finish that, and we can run this. I'm going to switch to a different simulator, and then we'll just run this really quickly, and the simulator will pop up. We've actually got it here already. It's now compiling the code. Swift takes a little bit longer to compile than Objective-C used to, but it's getting better every day. Compile the code, fire up the app, and we have a fully interactive map. At the world scale, of course, because we just specified the base map, we didn't specify any more information about this, but we can interact with this, rotate it, it's the vector tiles, and we can zoom all the way in and start to see different levels of detail. Now it's a little slow here in the simulator, but on a device, this is very, very smooth and lightning fast. Now, okay, so we want a slightly better area of interest. So let's replace this map with another version of the constructor. Here we'll go down to here, and we'll do navigation vector again, and we'll do Palm Springs latitude. I've got a little shortcut there. I've got a little shortcut for the longitude, and we've got a zoom level 15, and let's run that. And you'll be very unsurprised to see the app fire up again, but this time with a different map extent. It'll be zoomed in on the convention center in the Renaissance Hotel here in Palm Springs. And again, it's a fully interactive map. We can zoom, we can rotate, we can zoom out, all with just a couple of lines of code. So you saw how quick and easy that was to actually get a map view, an interactive map view, displayed in your app. I'm going to press Command dot here to stop this running. And let's make this a little more interesting. Let's add some search capabilities here. So, first thing I want to do is I'll add a search bar. We'll get rid of that assistant editor. Let's make a little room for the search bar here at the top. Up here, again, instead of a UI view, I'm going to add a search bar. And I'll just drop that in with the space at the top here, line it up there. We'll get rid of that constraint and just make the map view fit snugly against it. Now, you can see some red icons here. That says the view doesn't really know how to draw itself. It doesn't have all the information it needs. So first thing, I'll control drag from the map view up to the search bar and say I want the vertical spacing to be 0 like that. And then for the search bar, we have to snap that to the top, left, and right, like we did with the map view before. So we'll add these constraints, and then the map view will be happy to draw itself. And the whole structure is okay. There's no arrows here pointing to that. Okay, so in the view controller, we want to be able to respond to that search bar. And the way you do that, we'll add an extension to this view controller, and let's call it the UI search bar delegate. We'll say this extension implements UI search bar delegate, and that's how the search bar talks back to this view controller. Now, just quickly, before we forget, in here, in the UI view, we have to tell the search bar that the view controller is the delegate. So we'll just right-click on the search bar and drag this delegate connector up to the view controller. So now, anything that happens on this search bar, our view controller will be notified through this search bar delegate. So the one delegate method we're really interested in was search bar search button clicked. You can see in Xcode, we can just type different parts of the same thing to narrow down the autocomplete. So I just typed search clicked, and we came up with that. Press enter, and it fills in a dummy version of the code here. We'll do something real quick here. We'll just say that search text equals search bar dot text, and I'll actually turn this into a guard statement. Guard let search bar else return. What this means is if there is no text to search for, we'll just leave this callback method. So when the search bar calls into this method, if there's nothing to search for, we'll just leave it alone. Well, now we want to do some searching. To do that, we need to create a locator. So I'm going to say locator task equals ArcGIS locator task. We can see we've got autocomplete again. We'll have a URL pointing to the world geocoding service. So that's here at geocode.arcgis.com. We now have a locator task that is attached to that service, ready for us to call operations on it. So down here, we can do that. We can go locator task.search, and you see I typed search, but really the method is geocode. We've got a few different options here. We're going to geocode with simple search text, and that, of course, is the search text we just created on line 29. And then in the next completion, we're going to get results or an error. Now, first thing we do is we check if there's an error. So if, and this is Swift shorthand for saying if error is not nil, let's make it a variable that we can actually refer to, and it's convention to make it the same name. So we've got this non-nillable version of this error object. We can just say print error geocoding, and we'll just include the localized description in there, and we'll return. So once the geocode comes back, if it comes back with an error, we won't bother processing anything else. We're going to put a little bit of Swift special control in here. What this means is that this callback, if the view controller is deinitialized while the geocode is going on, this callback won't hold on to a handle of that view controller. We're saying weak self. We're saying if self becomes nil, that's okay. Forget about it. We don't need to hold on to it. We don't need to execute. But what we do then is we say guard let self equals self. And what this means is we now have a strong handle onto our view controller as self, but only if the app hasn't shut down, if that view controller hasn't been deinitialized. Anyway, now that we have our view controller, we want to do something with the result. Well, we're going to display the result in a graphics overlay. So let's create that graphics overlay. Here, and just quickly we'll add it to our map view. Location overlay. All right, so now our map view has a place for us to deposit graphics on it. The graphics can be points, lines, or polygons. They are not stored in a database. They're ephemeral. They sit on top of all the operational layers in the maps and the base maps. And so now let's start looking at that result. So if we get a result, and remember we've got an array of potential geocode answers, we'll take the first one. And we can make this a guard as well, so that we can simplify the code. We'll just jump out if there was no result. Now we can say if there was an extent on the result, we'll create an extent object. It has an extent property, which is optional. You can see here the question mark after the type means that it could be nil. Well, if it's not nil, let's declare this extent variable and do something with it. So I'm going to go self.mapView.setViewPoint to a viewpoint. And that viewpoint, we'll use autocomplete here. We want to set that viewpoint to the extent. So whatever the geocoder comes back with as being the extent of the result, we'll zoom the viewpoint to that. Now, if there was a location that came back with it, display location, you'll notice their geocode results have a few. There's an input location, a route location, which would be a street, perhaps the street address. The display location would be the rooftop address. So we want the display location. Then let's add a graphic at that point and display it. So we've got the graphics overlay on the map view for displaying locations. Let's create a graphic and add it to it. So let graphic equals ArcGIS graphic. You see this has a few different things. It takes a geometry and a symbol and optionally some attributes. In fact, all of these are optional. So we're going to use the location. We're going to create a symbol, and we're going to make it a simple marker symbol. That takes a few different properties. We're just going to make it a circle. We're going to make it red, and we're going to make it 12 points in size, and we won't provide any attributes on there. Okay, so we've got a graphic. We're going to say self.location overlay.graphics, add the graphic. And so now the overlay will take that point, a red dot, at the location of the geocode result and display it. A couple of other things we'll do really quickly. We'll hide the keyboard. This is an iOS trick, so any UI component can be the first responder. In the case of the search bar, that means the keyboard displays. We want to hide the keyboard. And actually up here, before we even do the search, we'll just do a quick location overlay.graphics.remove all, so that we only display the current geocode result. So we've wired the search bar delegate up to the map view. We've created ourselves a locator task and an overlay to display results in. We've added that overlay to the map view. Here in the locator task, here in the search bar delegate method, we call locator task geocode with the contents of the text in that search bar. We check for an error, we see that we have a result, we zoom, we set the extent appropriately, and we display a result. So we could type Palm Springs in here, and the map zooms appropriately. Notice how the zoom is contextual as well. So we can do Eiffel Tower, Paris, France, Europe, and so forth. So each geocode result comes back with not just a location, but actually an extent that's appropriate for it. So we can jump over to Esri Redlands and see the campus there. Okay, that's great. Okay, so we covered quite a lot there. Let's just summarize it. We introduced the map and the map view and how they work together and complement one another. We saw a lot about working with Xcode, in particular autocomplete, and working with storyboards, wiring them into the code behind. We talked about geocoding with the ArcGIS locator task. We learned about viewpoints, and we learned about graphics and graphics overlays, and how symbols work to display graphics on a map. So I just want to cover something very important that we introduced there and be very explicit about it. That's the task pattern. We saw the locator task. We created it with a URL that was pointing to our world geocoder. It could also point to a route solver, for example, or a local file on the device, depending on the task. In this case, it was the locator, and we called an action on it. Now, with any task, you connect it to the source and you call actions on them. Here we called geocode with search text. We got the callback block. The general pattern is to inspect for errors and then work with the results. Okay, we saw during my overview of the web pages as well of developers.arcgis.com the fundamentals section. So if you want to learn more about tasks and job patterns, check out the documentation there. Also loadable resources. A lot of what we work with in the runtime is asynchronous. It's remote. It takes a while to get a response from it. And we have a very strong loadable pattern that we make use of internally within the runtime to make sure you don't have to worry about things that are dependent upon one another. but also gives you great control over loading those things and waiting on dependencies yourself. We have a convenience method as well called ArcGIS load objects that will load a bunch of loadable things together so that you only have to make one call to wait for many things to be ready. Okay, so with that, let's jump back into our code and build upon what we've built so far to display some data on your map. Okay, so back in our project, we're going to add some data to the map. So to do that, first of all, let's just refactor this a little bit. Xcode has some really nice capabilities here. We'll pull this out to a method, and we'll call this make map. Now, so let map equal, and we'll return the map. So now we have a function where we can set up our map. It's just a little neater. So we've created our map with the navigation vector base map tiles at this location. We want to add a feature layer to it. So to do that, you create a feature table which points to the service, and then you create a feature layer from that table. So let's say that feature table equals ArcGIS feature table, and we're going to have a service feature table. Because there are different kinds. You could have a local geodatabase feature table or a service feature table. And here we're going to point it at the URL, and we're going to say so there's a Palm Springs shortlist. This is a feature layer that's already styled, configured for us. We'll create a layer from that, and we create a feature layer object, and we pass in the feature table. And the last thing we do is we add that to the map's operational layers. So when we run this, we'll see the same map we just saw centered on Palm Springs, but now it'll have some data on it. Now, that data will be styled, symbolized, and the map will still be completely interactive. But as we'll see, there's nothing we can do to the data. So we can zoom in, we can see these items on the map, but when I tap on them, nothing happens. So let's fix that. We'll jump back to our code, and the way we do that is we have to tell our map view how to handle touch events. So map view.touch delegate, and we see this delegate pattern again. And we'll say equals self. So we want us as the view controller to handle touch events on the map view. Now, Swift has noticed that we don't actually implement the delegate that we need to. So let's do that right here. Let's create a new extension on view controller. In this case, we're going to call it a GeoView touch delegate. So this is shared between scene views and map views, is why it's called GeoView rather than map view. So now we'll see that red disappear. So now we are a valid target for touch events. And what we want is GeoView did tap at screen point. You see I just typed GeoView tap, it highlighted that. Okay, so now we want to say, well, what happens when we tap on the GeoView at the screen point? So here we'll say map view identify at the screen point. There's multiple identify overrides. We want to identify regardless of layer. So we'll identify layers at screen point. And here we just pass in what was given to us in the delegate method. There's a screen point where the user tapped. The tolerance of 20 is typically good. We will get the full objects back, not just the pop-ups. And then let's fill in this completion handler. So again, we have results and an error. And we'll handle the error. Just print it out for now. Return. But then if we do actually have something, let's display something for it. So we're going to display the callout. The map view actually has a callout built in, and this allows us to display information, a couple of lines of text, or you can provide your own custom view to it as well. So if they have a result, if we got a result back, that will be an identify result. We can say we can get the feature out of that result. And actually, we want to be dependent on this too. So we can say if we got a result and that is an AGS feature, that represents an AGS feature, then let's jump into this if block. So now we can say, you can see we're being a little untidy here. What we should really do is we should have our weak self again so that we don't introduce a memory leak. That is to say, don't hold on to the view controller as self, but if it is still around when we finish the identify, then let's hold on to it for the length of this call. So at this point, we can say self.mapView, and it has a callout, and that callout has a title property. And we'll set that title property to the feature, one of the feature's attributes. The callout also has a second text field, details, and we'll do the same here. And the last thing we'll do is we'll actually display the callout. We have a few different ways. We're going to display it to represent a feature, so that later, if we need to find out what that feature is, the callout will have held onto it. And here we've got the feature object, and it was tapped at that map point that came in through the GeoView touch delegate. And yes, let's animate the display of the callout. If there wasn't a result, let's hide the callout. Okay, so let's run that, and we'll see that same map that we just saw, only now when we tap on it and interact with it, we'll actually get a callout for the various items in the map display. And it will display some information from the feature. So this is information coming down from the feature layer, from the feature service. Okay. Quick review of what we just saw there. Pretty quickly we were able to add data to our map using a feature layer. And we've got this model of the table, the feature table, which points at the data source. We looked at a remote service, but it could be a local geodatabase on the device or a shapefile. And then you create a layer from that feature table, and the two work together to display the data on the map. We saw some map interaction with GeoView Touch Delegate being able to tap on the map. And we saw reading feature details and then using a callout to display some of that information. Okay, so for this last demo, we're going to really build upon that stuff and introduce routing and directions, as well as working with the GPS. Okay, so for this last demo, we'll take where we left off before with feature data on the map and being able to tap callouts, and we'll get directions from where we are to whatever we tapped on. So let's start off by creating ourselves a route task. So I'm going to take some shortcuts here, but what we've created is a route task property, and here we have a closure that actually initializes that for us. So we've got an ArcGIS route task that points to the world routing service. Now this requires a credential, so we've actually got a demo credential set up somewhere else. It's hidden away. I don't want to show you that username and password, but you create a credential and give that to the route task object, and it will be able to authenticate to make use of directions. We also want a place to display the route results, so we'll create another overlay like we did for the location results. Only here we'll go into a little more detail. We'll actually initialize the overlay in a bit more depth. So we're creating the overlay as usual, but now we're going to use a renderer on it. So before, we added the location results with their own symbols attached to the graphic. So when we created the graphic for the geocode result, we created that simple marker symbol, the red dot, remember? And every graphic would have its own symbol. Here we're going to have the graphics overlay responsible for rendering any graphics that are put in there. So we'll define a renderer. In this case, everything is going to be rendered with this same orange 10 width solid line. And any graphics, any polyline graphics that we add to this overlay will be represented in that solid orange line. So when we add the graphics and create them, we don't actually specify a symbol for them. We just specify the geometry, and in they go. Okay, so now that we've created a route task and a place for the route to for the route results to be displayed, let's make sure we add that route overlay to the map view along with the location overlay. So we now have two graphics overlays in the map view, one for location results, one for route results. And since we're going to be using the callout, let's configure the callout a little bit. We will do a couple of things on it. First of all, we'll set the accessory button to this arrow in a diamond, indicating that if you tap that accessory button, it will end up getting directions. And secondly, we'll say when the callout has something to report back, some operation, in this case it's going to be tapping on the callout to call back, let us be the delegate for those callbacks. The last thing we want to do is start the location display. So the map view has a location display. That's the blue dot experience you want in a GPS app, and we're just going to call start. And of course, we may get an error. Then we need to report that to the user some way. In this case, we're just going to print it to the console. But you would probably want to display an alert of some sort. But otherwise, the blue dot will have started. Okay, but before we can start the location display, iOS requires that we actually declare a string that's going to be displayed to the user by the operating system, asking them if it's okay for us to start location. So this is down in privacy and location when in use description. So when we enter this text, in this case, we want to get you to there, then this is a text that the user will be prompted with when the application first tries to access the GPS. You should be used to seeing this when you're running iOS applications. The operating system makes this query for you. Okay, so let's run this. Okay, so here we see the text that we entered. We want to get you to there. Allow while using, allow once, don't allow. Let's say allow while using. The app starts up, and there's the blue dot at our location in the Renaissance Palm Springs Hotel. Now, when we tap on a location, you see this icon is now this directions arrow. And when I tap on this, the runtime goes off, gets directions to that location, and prints them out in the console. So let's take a look at what's just happened in the code there. The first thing we did was we configured the callout to show that different accessory button, and then the delegate to tell the callout that when we tap it to call back to our code. We can see down here, we then implement the callout delegate did tap accessory button. So when I tap that directions button in the callout, I'm going to get directions to the feature that was represented by that callout. And I start off by getting hold of that feature. Remember when we displayed the callout, we showed it passing in a feature, it held on to that, and so now we're getting it back out. We also get the location. That's the destination for our directions. So we're going to go from the blue dot, which is where we are, to the feature that we tapped on, and we get hold of that feature location. We're going to use that in a second. Then we take the route task that we created and we get some default route parameters. The World Routing Service has default settings for driving, but if you publish your own route task, you can have your own default settings as well. So we provide a method for getting hold of those, and then we make sure that we actually have the start location. So we look at the map views, location display, and map location. So at this point we have the feature location and the map location and some route parameters. We're now going to modify those default route parameters for the directions we want. First of all, we're going to set the output spatial reference to match our map because we want the route result to be displayed on the map. Let's not give ourselves extra work to do once we get that back in terms of projecting it to the right spatial reference. Let's get the route task to give it back to us in that correct reference. And we want return directions to be true. You see here, we were able to print out the turn-by-turn directions, and that's because we set this property here. Then we just set a couple of stops. We set the end stop, which is the feature that we tapped on. So we give it the feature location. We can set a property on it based off the attributes on that feature. This is the same attribute we showed in the callout. We're going to pull it out here, and if there isn't one, we'll just say my destination. And we'll do the same for the start point using the map location we got out of the location display, and we'll give it a name of my location. So that will give the directions a little more context. You see here again, start at my location, that's this text here, and finish at Hard Rock Hotel Palm Springs. And that's the text that comes out of this name attribute. So once we've set up these stops, the return directions, and the output spatial reference, we simply call solve route with these parameters. Make sure that we get a route and that it has a geometry. And if it does, then we create a graphic for it. Here we just create a graphic with the geometry. We don't specify a symbol because if you remember, we created the route overlay to have a renderer that will draw everything in that orange line. So all we then need to do is set the graphic on the graphics of the route overlay. Now previously we did a remove all. Here's another shortcut. We can just create an array with just the graphics we want to display and set that array on the route overlay graphics. The last thing we do is we set the extent of the map appropriately. So we get the extent of the geometry that came back for the route, but we actually want to make the map a little bit bigger than that. If you see here, we've got a bit of an extent around there to give us some context so that the route doesn't just butt up against the edge of the map and make it hard to read. We do that by converting the route geometry's extent to a builder. Now all geometries, including extents in the runtime, are static. That makes it much easier for us to draw and work with high performance. But it does mean that if you want to modify the geometry, you have to first of all convert it to a builder, then make the modification. In this case, we're expanding the extent by a factor of 1.4, and then we turn it back to a geometry, which in this case will return a new extent. We then just set the map view's viewpoint using this override and set viewpoint geometry to the route extent, and you'll see when we look at various set viewpoint methods on map view that some of them have a completion block and some of them don't. If there's no completion block in the runtime, it means it's going to do it without animating. If there's a completion block and it's a view-based thing, in this case the map view, it's going to animate. So here we're setting the viewpoint with an animation. Even though we don't do anything when the animation's finished, we know that this is going to animate, and that gives us a little more context as well. And the last thing we do is we print out the directions here to the console. Okay, so a quick review of what we just learned there. We saw another task in action. We saw the ArcGIS route task. Previously, we'd seen the ArcGIS located task. In this case, the route task requires credentials. So we needed to provide a credentials object to be able to authenticate to use the route task. We saw geometry builders in work, demonstrating that geometries are all static. To create modified geometries, you have to first convert them to a builder, work with the builder, and then generate a new geometry from that builder. We also saw viewpoints with animations and how that can be used to add a little bit of context to your app. And we also introduced the concept of renderers, where your features or graphics can just be presented to the user, and the renderer takes care of exactly how that presentation happens. Okay, so a lot of asynchronous stuff going on here. I mentioned the loadable pattern. When you're working outside of the runtime as well, if you need to coordinate these asynchronous objects, iOS actually includes a really powerful framework called Grand Central Dispatch. I recommend you take some time to learn Grand Central Dispatch, learn a little bit about it. It's very, very powerful and really abstracts the complexity of threading away, makes it very easy to write really responsive, performant applications that can make good use of multiple threads. Something that iOS provides is something called key value observation, where you can say, hey, I want to know when this property on an object changes. Now, KVO, as it's called, could happen on any thread. So Grand Central Dispatch makes it it comes in very handy, because it's very important when you're working with user interface to do your user interface work on the main thread. Otherwise, iOS will complain and Apple probably won't allow your app into the App Store. So if you're observing a property such as, for example, map scale, and you need to update a text label somewhere, make sure you update that text label by dispatching the update to the main dispatch queue. Again, I recommend you spend some time learning about dispatch groups and Grand Central Dispatch and KVO. These are all key iOS developer concepts and very useful. One thing the runtime provides is a dummy location data source. So we saw working with the map view's location display, by default, that has a data source that taps into iOS's own GPS libraries. But if you have a GPX file that you want to simulate, we provide a GPX location data source, and you can set that on your location display to read the GPX file and have your blue dot follow that around. There's also a useful little library or couple of Swift files that happen to be built as part of the data collection iOS application, and those can output information telling you exactly which version of the runtime you're working with. This is very useful if you're building an application, you want some debug logging or you want some crash logging. Feel free to take a look at this URL and jump in and see that. Okay, 3 quick things to finish with. Runtime has strong 3D support. We saw that in the demo of the sample viewer. There's a lot of really good 3D analysis you can do in the GPU on the device. Bear in mind, though, 3D applications in the simulator are not good. The simulator has OpenGL emulation, and it's very, very slow. However, as I mentioned earlier, things are going to change with Catalina, Xcode 11, and iOS 13. At that point, you can run Metal directly in the simulator, and Runtime 100.8 will support that. So, working with scenes in the simulator, if you're doing it on Catalina, Xcode 11, and iOS 13, or later with all of those, then you'll be able to get a lot better performance out of it. But generally, it's a good rule of thumb not to rely on the simulator for real-world performance. I mentioned earlier open source apps. They show best practices for building real-world apps, and you can just steal what you want or use them as the foundation for your app. I've mentioned the data collection app already. And also we provide a toolkit. Each runtime has a toolkit. And the iOS toolkit is available on GitHub. It's open source, it's written in Swift, and it just adds components that come in handy when working with the runtime, such as a compass or a scale bar. The most important thing, really, as I alluded to when talking about 3D and Metal, is to test in the real world. You should test on actual devices to get real performance metrics. You should test with real people because they're very, very adept at finding ways to break your applications. And you should test in the field with real network conditions. Network conditions vary drastically, and it's very important to see how your application, as you've written it, works with variable network conditions. Now, the runtime tries to take care of a lot of it for you, but it can't do everything. You need to be aware of that and build your applications around it. So in summary, we covered what's available to you to get started over at developers.arcgis.com, and then we jumped into some core workflows. We introduced the map in the map view, being able to display graphics or features which are connected to data sources, Being able to use the task pattern. We showed geocoding and routing, but there are other tasks as well. The location display for working with the device's GPS, geometry builders, and the static nature of geometries, working with callouts, and the map view has a callout built in, and handling map view interaction as well. And so with that, I want to thank you very much for listening. I hope you've learned something about the Runtime SDKs and this has been helpful to you. Thank you very much.